Hey guys, so today we're going to dive into trigonometry and trigonometric ratios, which is a ratio of the lengths of the two sides in a right triangle. So when we were discussing similarity, we were looking at the proportional sides. This is very similar. So we're going to focus on three. There are many more, but for the remainder of the year, we're strictly going to worry about sine, cosine, and tangent functions. And it is read sine of angle A or sine of A. Here is angle A. And it's important to understand what sides of the legs we're talking about. So, line segment BC is the opposite side of angle A. Notice how it is across this angle. It is the opposite side. The adjacent side is the angle that just touches that angle. So this is the adjacent side. And the hypotenuse is always opposite the right angle. Now to distinguish the trigonometric ratios, we have sine of A, which is the length of the leg opposite to angle A. So that is this guy, A, divided by the length of the hypotenuse. You see in purple, C. So these are values because we're talking about lengths, but in the general sense, we're looking at this right now. So cosine is the length of the leg of the adjacent side, so that is B, divided by the hypotenuse. And lastly, the tangent function has a ratio that is the opposite of A divided by the adjacent. So it is the opposite divided by the adjacent, or A over B. You can abbreviate the ratios as so. Instead of writing sine, cosine, tangent, as you see up here, you can abbreviate them as sin of A. It's still read sine of A is equal to the opposite over the hypotenuse. Cosine is abbreviated as cos of A is equal to the adjacent over the hypotenuse. And tangent of A is equal to the hypotenuse over the adjacent. So again, these are the abbreviated versions of my trig ratios. So we're going to strictly look at sine and cosine for right now. So the sine and cosine ratios are trigonometric ratios for acute angles that involve the lengths of the leg of the hypotenuse of a right triangle. And the hypotenuse of a right triangle, excuse me. So this hopefully is redundant, but I want to make sure you understand it. Sine and cosine ratios. So we're looking at the angle A. And here is my angle A. And the opposite of angle A is the green line. And the adjacent is again the side that is next to my angle. And again, the hypotenuse is always the opposite side of the right angle. So sine of A is the opposite divided by the hypotenuse. While cosine is the adjacent divided by the hypotenuse. Let's take a look at a few examples so that we can discuss this a little further. So find sine of S and sine of R. So before I begin, I want to identify the hypotenuse, adjacent, and opposite side. So here I have my angle S. The opposite side to angle S is 63. The adjacent side is 16. And this is my hypotenuse. So here I have sine of s is equal to the opposite of angle s divided by the hypotenuse. So the opposite side, we see that it is 63, or excuse me, RT divided by RS. You can see that here, RT divided by RS. These are the two values I'm concerned about. And I have 63 divided by 65. Now I'd like you to do the same. I'd like you to find the ratio for sine of r. I'm going to start you off here, and notice that here I have angle r. So my opposite side is now 16. My adjacent side is 63, and my hypotenuse is always the hypotenuse. So notice the difference. Before, I had this angle. I had 63, 16, 65, and this for sine of s was my opposite side, and 16 was my adjacent side. So make sure that you are using the right angles, the right reference angles. So take the time to see if you can figure out what sine of r is. Hopefully you got 16 over 65. Because again, it is the adjacent side divided by the the hypotenuse. Said that right. Just didn't highlight it right. Great. So now we have cosine of s and cosine of r for the same triangle. I'm going to start the first one. I have my angle s. Again, the opposite side of angle s is 63. The adjacent side is 16. And the hypotenuse, again, is always the hypotenuse. So cosine of s is the adjacent side of s divided by hypotenuse, which is equal to the line segment ST divided by SR, which happens to be 16 over 65. Now, cosine of r. We have to remember again that this is my reference angle and the opposite side is 16. The adjacent side is 63. And the hypotenuse is 65. Take the time, see if you can try to figure this out. Hopefully, you got 63 over 65. Great. So, the tangent ratio. Last trigonometric function that we're going to look into. The tangent ratio is a trigonometric function for acute angles that involves the length of the legs of the right triangle. So very similar to sine and cosine, just that we have the leg of the opposite side divided by the adjacent side. So taking a look again, angle A, the opposite side of angle A is line segment BC. The side next to angle A, or adjacent, is line segment AC. So an example of that is here. I want you to find tangent of S and tangent of R. Here I have tangent S, angle S, and so the opposite side of this angle is 80, and the adjacent is 18. The hypotenuse is always opposite to the right angle, as so. This is very important because it's going to make our lives easier. Tangent of S is equal to, hopefully you remember, you can refer back to your notes, the opposite over the adjacent side. So that is RT divided by line segment ST, which is equal to 80 divided by 18, or 49ths. Now at this time I'd like you to take a look and try to find the value for tangent of R. If you need to redraw the triangle, you can, just like I'm doing here. And notice that 18 is now my opposite side. 80 is now my adjacent side. And we have my hypotenuse 82. Hopefully you got 9 over 40, which should make sense because it is in reverse, right? Tangent of S is the opposite of S over the adjacent, and now tangent of R is the opposite of R divided by the adjacent to R. If you're wondering, how am I going to remember this? This is a lot. Well, we have an acronym for you. SOHCAHTOA. So we have sine is equal to the opposite divided by the hypotenuse. Ka for cosine is equal to the adjacent divided by the hypotenuse. And lastly, TOA is for the tangent, which is equal to the opposite side divided by the adjacent side. So SOHCAHTOA, the sooner you can memorize this, the better. It's going to help you calculate different trig functions quickly for ratios. So here I left this up for you. I want you to find sine, cosine, and tangent ratios for angle T. So before we begin, we have the opposite side, which is 8. That means that this is my adjacent side, and this is my hypotenuse. So the sine is opposite over the hypotenuse, so on, which is 8 over 17, the opposite divided by the hypotenuse. Cosine, you should see that it is the adjacent over the hypotenuse. Which is equal to 15 over 17. And lastly, we have the opposite over the adjacent for tan of t, which is equal to 8 over 15. Hopefully this is starting to make sense. Now I'd like you to try. Find tangent of j and tangent of k, and write each answer as a fraction. Don't worry about a decimal at this time. It's just using your calculator. Great. Hopefully you found that it was 3/4 for tan of j, and 4/3 for tan of k. For the second one, 8/15 for tangent of J, and 15/8 for tan of K. Great, hopefully you got that. Now what if we don't have the sides, but we have an angle? Before, we were given an arbitrary angle, and we were asking you to find the ratio. However, we're going to use the trig functions to find out the side lengths. So before we do that, we have to write it out. So normally, what we've done so far is we said, all right, sine of A is equal to the opposite over the hypotenuse. However, in this case, sine of A, angle A, is 26. So instead of writing a variable, I'm going to say sine of 26 is equal to the opposite over the hypotenuse. Substituting those values, I have sine of 26 degrees is equal to x over 14. Going to multiply 14 on both sides to solve for x. And using my calculator, you're going to type 14 times sine. In your calculator, you'll see that these will have a parenthesis. You need to close the parenthesis, and you'll have sine of 26. The calculator will tell you 6.1 is the value of x. Now, let's take a look at y. Which trig function could you use that encompasses y? There are two. In this case, we're going to use cosine. You could have used tangent since we were given the opposite side. But let's take a look at how cosine looks. Cosine of 26 degrees is equal to the adjacent, right, my value of y, divided by the hypotenuse, which is already given. So substituting those in, and again multiplying 14 on both sides, I get 14 times cosine of 26, which is approximately 12.6. Now, let's take a look at how we can solve and use trig functions to solve real life problems. Here we have angle of elevation and angle of depression. Take the time to write this down so I can show you a few more examples. Okay. Here. I want to measure the height of this tree. I know that my horizontal distance is 45 degrees and my angle of elevation, so I'm starting from the ground and I am finding the angle to be 59 degrees. Which trig function can I use to find the opposite side, which is the height, and uses the adjacent? The reason why I can't use the hypotenuse is because I do not know this length. So again, which trig ratio can I use that works with the opposite and adjacent side? Hopefully you said tangent. And setting up the equation, you would say tangent of 59 degrees is equal to the opposite divided by the adjacent side. So substituting h for my height, I have this. I'm going to multiply 45 on both sides. And I have a height of approximately 74.9 feet. Pretty cool, huh? Now let's take a look at angle of depression. So we're going down a ski slope. The angle of depression, so from the point sloping down, it's 21 degrees. I know that the altitude is 1,200 feet, and I want to find out the distance traveled by my skier. So hopefully you got this down by now, but this is my opposite side. This is my adjacent side, while the value of x is my hypotenuse. So what trig ratio would I use to find the value of x? Sine, cosine, or tangent? Hopefully you said sine, because if you remember, sine of an angle is equal to the opposite over the hypotenuse. For that so in SOHCAHTOA. But instead of an angle A, it is going to be 21 degrees. So sine of 21 degrees is equal to the hypotenuse divided by, the opposite side divided by the hypotenuse side. Substituting my values, I have this. Now I will cross multiply. To get x times sine of 21 degrees is equal to 1,200. Dividing sine 21 degrees on both sides. And I'm going to use my calculator at this point. So 1,200 divided by sine on your calculator, you need to put your parentheses. Sine of 21 degrees is equal to 3,348.5 degrees. If you did not get this answer when you put it in your calculator, you must make sure that the mode in your calculator is set to degrees. If it's under radians, you will get a different answer. You will learn more about radians in next year. So we are strictly looking at degrees. So using your calculator, you must make sure it's programmed to calculate 21 degrees and not 21 radians. If you need help doing that, reach out to me and I'll help you with your calculator. So the ski slope is about 3,349 feet down the mountain. Awesome. Now let's take a look at a few more examples just to bring it home. Here I want you to find sine of D, sine of S, cosine of D, and cosine of F. So let's take a look at D, angle D. Line segment EF is my opposite side. This is my hypotenuse side. And line segment DE is my adjacent side. So sine of D is equal to the opposite over the adjacent. So 7 over 25. SOHCAHTOA. And sine of F is a bit different. Doing this in a different color. The opposite side is 24. The adjacent side is now the 7. And this is still my hypotenuse. So sine of angle F is equal to the opposite over the hypotenuse. So 24 over 25. Just like you see here. Cosine uses the adjacent and the hypotenuse. And that gives me 24 over 25 for cosine of D and 7 over 25 for cosine of F. Now let's take a look at the third example. I want you to find the values of u and t using sine and cosine. Round your answer to the nearest tenth. So, actually it tells you the trig function. So, let's label our sides again. Well, t is my opposite side. This is always my hypotenuse and my adjacent. So, in order to do this, I have sine of 65 degrees is equal to the opposite over the hypotenuse and cosine of 65 degrees is equal to the adjacent over the hypotenuse. Solving for t and u, you should approximately get u is approximate to 3.4, t is approximately 7.3. Great. And that's it. That is a brief review of trigonometric functions and ratios. We're going to be dealing with trigs for a while now, so you have a lot of practice in the coming weeks. Hopefully this was understandable. If not, feel free to reach out to me or rewind the video and watch it again. Thanks.